Hello everyone, we are solving Leetcode today. Top K element, top K frequent elements. So let's just jump right into solving this question. Given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. Okay, pretty straightforward question. It's a medium type question, but it's a pretty straightforward question. Nothing too complicated about it. We just have this array here, nums. We have a couple of numbers here, and we just need to return the k most frequent element. So here k is 2, meaning that we need to return the two most frequent elements in this array. As you can see, 1 is the most frequent and 2 being the second most frequent element. Perfect. Here, same thing. Um, Here as well, we have the same thing going on. Okay, perfect. It's a medium type question, but to be honest, it's pretty easy. As a beginner, what should we do? As a beginner, what intuition should we have in order to solve this question? So um, let's just see. We have this array, we have these numbers, and we need to return the top frequent element. So uh, we can just parse the array and have a table where we have a number and its frequency, right? So in that case, we're just going to use a hash map. Okay. Let's use the hash map where we will have a frequency, we will have element, right? And we will have frequency, right? Perfect. Now, you need to have essentially we just need to the take out the k most frequent element, and that's it. We have our answer, right? So how do we go about solving this question? So um, hash map, we just need to declare it here. Perfect. It's pretty easy. Um, my bad. Hash map and integer, and then we are going to call it a map, right? And then just hash map. Um, and now we will have of our favorite for loop. Int is int I equals to 0, and then int must be less than nums of length, and then I plus plus. Perfect. So we have our for loop. Okay. And now what? We can have a simple check. If our map contains the key. So if our map contains the key, what? Nums of I? All right. If it contains it, perfect. We just need to increment the frequency. So map.get what nums of I. So that's our frequency, and we need to put it in the map, right? So map dot put, and then we just put what nums of I as our number element, and the frequency here is this, and we just need to increment it. So we're going to increment it. How? We're just going to add 1 to it, and that's it. That's how we're going to add it. And let's just say if we don't find it, then we just need to put the same thing. Is just we're gonna have 1 in place. That's it. Perfect. So we have a clean table here. Our hash map, we have our element, we have our frequency. Perfect. What next? We need to somehow um, have our numbers arranged in such a way that we have um, the most frequent numbers either at the above or at the bottom. Um, so if we have our most frequent numbers at the bottom, that means we will have the less frequent number at the top, right? And if you remove those numbers, from above, you will just be left with the answer. So you can use a min heap in this case, right? Why? Because all the useless frequencies, all the numbers that are less than the required number, less than k essentially, they will be at the top. So in this example number one, 3 is going to be at the top in the min heap, in our min heap, and then 2, and then 1 is going to be at the bottom. So we're going to remove 3 because that's the useless number. We don't need that because k is equals to 2. We need to have two numbers. So the rest we will have two numbers, and these will be the most frequent numbers. So we'll have a min heap. How we will have a min heap? Pretty easy. We are going to use a priority queue, right? So we'll have a priority queue set up here. Perfect. Type integer, and we're gonna call it PQ, and new priority queue, and that's it. To declare a priority queue, a min heap, we need to pass the parameters here, A and B, where map dot get A minus map dot get B. Okay, so we're just comparing it, and that's it. We have our min heap here. Perfect. And that's it. Now what? Now we just need to add numbers to our min heap. How are we going to add it? For loop. In fact, we're going to use for each loop. So we will have for each num, not num. We'll call it key because we're gonna get all the um, key sets. So key set, and okay, we will have key set here. Perfect. So now that we have all the keys and the frequencies are arranged, so we just need to add it, right? So pq dot add. What we're gonna add? We're gonna add keys essentially. So we're gonna add keys to it, and we're gonna have a check here. Check will be regarding the size of our queue. So the size goes greater than k, then we can always remove the element. So we don't need unnecessary elements, right? Um, this will maintain the size of the queue. And now that's it. Now we just need to prepare our answer, right? Why? Because we need to return an array. We need to have an array then. So we're going to call it a res. So result and of size k. Okay, size k is good enough. And we're going to have a for loop where we're just going to have it run from k minus 1, because at the bottom we will have all the numbers, the major numbers, our result will be at the bottom of the min heap, right? So we'll start from the last index, and we're gonna make sure that it's greater than equals to 0, and uh, decrement it. Perfect. And now what? Result array of I will be equal to pq dot poll, right? We'll have the result prepared, uh, and we can just return. We can return our result, and that's it. That's how we will have our answer. Let's see. Okay, it says contain my typo. Okay, it's okay. Perfect, accepted. Perfect. So this is one way of solving this question. Okay. Second way of solving this question would be, so right now we are storing a hash map. We have that hash map, perfect, and we're using a priority queue, right? We have a priority queue, a min heap where we are essentially having the minimum number at the top and we're removing it, and yes, that's how we're getting the answer. Um, another good way of solving this question, another smarter way of solving this question is using something called buckets. So um, what I mean to say is we can have an array set up where the length, where the index of the array represents the frequency. Because if you see, okay, if you see the maximum frequency of any given element here is the length of the array. What I mean to say is one can only be repeating itself probably one, two, three, four, five. So probably equal to the size of this array. Like we cannot have, if the size is six, we cannot have seven ones, right? That would be illogical. So that's the maximum frequency we can have for one. Using the same concept, we can have a bucket. We can have an array where indexes represent the frequency, and on each frequency we can have the numbers that essentially have those elements, right? So hash table is pretty good. We don't need to touch it. But what we can do instead of putting it here in our heap, min heap, we can essentially have a list of integer. Okay, we're going to call it as list. Okay, and it's going to be an array. The list. Let's have a list. Okay, perfect. And now what we're going to do, we are essentially going to store um our elements in terms of frequency. So we can have um, a for each loop where we can have the number as num, and we can have map dot get, or not get, key set. Okay, we can have key set, and so now num, or else we can just call it, yeah, I mean it's key, right? It's key. We can have it key, call it key, and we can have frequency out of it, right? So we can call it as frequency, which could be equal to map dot get key. So now that we have the key itself and the frequency of it, perfect. And we can just check if um, the list, or else we can, let's just call it a bucket. Okay, let's call it a bucket. So if our bucket, and you know what, we can have a size also to it. So size um, could be nums dot length plus one, right? So because we are eliminating zero, and could be the size, and we can call it a bucket, and bucket of that specific frequency, right? If it's equal to null, if it's null, then we can just have, in that place we can just have probably a new array list, right? We can have an array list there, and let's just say if it's not null, if it comes down there, and if it's not null, we can essentially add the element to the list. What I mean to say is we can add bucket dot frequency dot add the number, which is num. And this is one way of doing it, and we can have essentially an array lists where the indexes represents the frequency, and at each frequency we have an array list where we have numbers stored. So just to have the result, what we can do is, since we need to assign, we're going to call it as res, and we're gonna have it called size of k, and for loop, and we're going to probably I equals to 0, and then I could be um, should we run it till 0, or should it be um, okay, how are we gonna add index? So let's just call index as 0, okay? And since the highest frequency is going to be the last one, right? So we can have um, bucket dot length. So essentially it's the nums of length, right? So we can have length, right? It was length, and then I could be equal to 0, greater than equal to 0, and index, our index should be less than k, and I minus minus. That's it. That's how we're gonna have our loop, and we can have our result prepared. So uh, let's say we are at one specific frequency, we get an array list. Perfect. So now we can just so we can have our um, array list explored, right? So how do we do that? Um, okay, we are iterating over our bucket, and so our bucket at position I, and okay, so we can have another for loop, and this time it can be called as for each loop, and where have we have elements, we can call it elements, all right? And for each loop of, and at that specific point, which is bucket of I, it will have an array list, and this will have elements, and we just need to add index, right? Index is equals to element, and we increment index, and that's it. And we can just return our result. Pretty straightforward. I will explain it to you what's happening here. Let's first run it. Okay. All right. Okay. Another compiler error. What does it say? Num. Okay, num. It's not num, it's key. All right, we're adding key. My bad. Okay. I am bad at naming my variables. What does it say? New. Oh my god, new int. Okay. I hope I don't get any more compiler error. Oh wow, great. So we have runtime error. So it's bucket of I. All right. Okay, we need to have a check as well. So we can have a check where bucket, where bucket at that position must not be equal to null, right? Because if it's null, then we will have a runtime error. Okay, perfect. So we have that in place. Set it up. Oh, perfect. That's good. Perfect. So it's much better than before. And yes, so what essentially we're doing here is we have this loop, okay, where we are starting from the last index, so num of length, and then making sure that it doesn't go below 0. And we have our index, an, a variable here, a counter variable here, to make sure that we have exactly k elements in our result. Okay, and so k is 2, so 0 and 1, and that would be the index. And we're decrementing pretty straightforward. So given spot, at a given spot, at a given spot meaning at whatever index that we are on, it's essentially representing a frequency. So if the length is 7 of that, so 7 represent a frequency. So 7 at 7 spot, we have an array list of numbers, and we first checking whether that array list is null or not. If it's not null, then we have all the numbers that repeating themselves 7 times. Um, and once we get to a spot where we have an array list filled with numbers, we just go to this for loop. We pick up each element and put it in the put in our result, and we just increment index, and that's it. That's how our last for loop is working, and we're returning the result. And yes, perfect. So thank you so very much for watching. This is essentially the brute force approach and the I would say a little smarter approach, optimized version of the same question, top k element, medium type question. So, but to be honest, the optimized version comes with practice. The intuition builds when you solve the same type of questions. Um, but yes, make sure whenever you see top k frequent elements, or k most frequent elements, or k this, wherever the frequency is given or the top segment is given where you need to find the top elements, um, try to solve it using min heap, or at least think of applying min heap, because that's a smarter way of solving questions. And after that, you can go on to bucket using buckets. So yes, that's another way to solve this question. And to be honest, the second optimized, much more optimized version is the most easiest one to implement. But yes, thank you so very much for watching, and I hope you're enjoying my content. Do like, share, and subscribe my channel, and see you in the next video. Bye bye.